Hello beautiful people, today we're doing 5.4 sampling distributions and the central limit theorem. Our SWABAT is to find sampling distributions and verify their properties, to interpret the central limit theorem, and to apply that theorem to find the probability of a sample mean. Sampling distribution. That's the probability distribution of a sample statistic, and it is formed when the sample size n, or samples of size n, are repeatedly taken from a population. For example, are also known as sampling distribution of sample means. New words for us today, but I think we'll get them pretty well. So you are already aware of what the mean is. It's the average. It's what we use as mu. The mean of a sample means, so we're going to pull out samples and then find the averages of those samples. And that's the same thing as the regular mean. It's always going to be equal to the population mean. It's a nice thing. Standard deviation is a little bit different. So the standard deviation of your sample mean is known as deviation, and this is an x bar right here. And that's going to be equal to the population standard deviation divided by the square root of the sample size n. And then that is also going to be known as the standard error of the mean. Okay, example 1. A population has a mean of 175 and a standard deviation of 32. Find the mean and standard deviation of the sampling distribution of the sample means with a sample size of n equals 2. So what you are now looking for is the mean sample and the standard deviation as well. Well, we know that the sample mean is the same as the other one. So if this mean is 175, this mean is 175. It's light, nice, and easy work. This one, you need the standard deviation of the population standard deviation, so that's 32 divided by the square root of n, and in this case my n is 200. Then you can punch this into your calculator and you will find that you will get 2.263. I'm going to round to the nearest thousandth. So for these problems, you're going to go for 3 numbers after the decimal point, just for nice accuracy. Okay, the next thing that we'd like to do, for example 2, is the population values 1, 3, 5, and 7 are written on slips of paper. So think of it, you have 4 pieces of paper. One has a 1, one has a 3, one has a 5, one has a 7. And then those 4 pieces of paper are put into a box. 2 slips of paper are randomly selected with replacement. That means you have all 4 of them in the box, you pull a number. And then the replacement part means you put that number back in and then you pick another one. So you're not picking 2 at a time. You're just going to pick 1, take it out, it's a 3, put it back in. Then you could get a 1, 3, 5, or 7 for the second slip. So what we want to do here is find the mean, variance, and standard deviation of the population. So the total population. So that's these numbers right here. These are my population values. Starting with the mean. Well, you know how to find the mean already because it's adding up all the numbers. So 1 plus 3 plus 5 plus 7. And that gives me 16 divided by the number of numbers 1, 2, 3, 4. So my mean of the population is going to be 4. Now they also asked me about the variance, and that's one that I don't think that we all remember. Variance is like the standard deviation, but it's that squared, and that's equal to the sum of x minus the mean squared over n. So what does that mean for s? Well, that means we're going to be adding like we had to add those ones, but for x, for the first one is 1, so these are your x values, 1, 3, 5. So for the first number, it's going to be 1 minus the mean, which is 4, plus the next number was 3, minus the mean, which is 4 squared, plus 5 minus 4 squared, and then plus 7 minus 4 squared, and all of that is going to be divided by n, the number of numbers, which is going to be 4. You do some math, you'll simplify. This is negative 3 squared, so that's 9, plus 1 plus another 9 over 4, and that's going to be 20 over 4, which is equal to 5. That's your variance. We don't really use that very much. No one completely cares except that they asked me to find it, so we did it. The standard deviation, which we know and love, is the square root of the variance. So the square root, in this case, of 5, which is about 2.236. All right, let's keep it pushing. If you could, please turn your paper over. So just for a reminder, our sample was 1, 3, 5, and 7. That was our population, excuse me. So for part B, we want to construct a probability distribution of sample means by first creating a list of all the possible sample sizes of size n equals 2. So remember, we're pulling one number, putting it back in, and then pulling another number. That's why the n is 2, because we're picking two different things. This is x bar, and x bar is going to be the sample mean. So that's a key word here. Sample mean, whenever you see that, it's x bar. Okay, let's look at that. So let's just kind of keep this nice and organized. I'm going to just apologize. Some things are just going to pop up because I'm left-handed, and if I accidentally push a button, then it's just going to pop on my screen. Touch screen, first world problems. So if the first number is 1, let's say I pull out a 1. Well, and then I put that number back. And then I'm going to pull out another number, and then let's say it's another 1. And then that's one sample because I'm picking two numbers. Well, what's the sample mean? Sample mean would be 1 plus 1 over 2, which would be just 1. Then I pick out 1 again, and then I got a 3 the next time. Picked out 1, and then I got a 5 the next time. Picked out a 1 again, and I got a 7. Those are all my possibilities of picking a 1 first. To find the sample mean, 1 plus 3 is 4, divided by 2, because it's two numbers again, and that would be 2 for that one. For the next one, 1 plus 5 is 6, divided by 2 is 3. 1 plus 7 is 8, divided by 2 is 4. So this is kind of a little bit tedious, and that's why you only have one problem like this on your homework. But I would also like for you to do the same thing for 3 and then for 5. So basically I want you to fill in all of these. You should have 16 by the end of it. Do that. Go ahead and press pause if you don't mind. And even if you do, press pause and complete that part. Okay, so hopefully you press pause, and then you should still have these numbers right here filled in. And if you didn't press pause before, you got to press it now so that you can get this information down. The next thing I want to do is, because this is kind of a long mess, I would like to organize this. So this is where I'm going to do the probability distribution part of it. And what that's going to be, because I don't think we all remember, we're going to have 3 columns. One is for the sample means. The second part is going to be the frequency of it, like how many times that particular number occurs. And then we're going to use that information to find the probability of each mean. Probability. Yes, I just sounded that out. Don't judge me. Okay, so the lowest number that I saw was 1, which would be this one, and that occurred, looking at the whole path here, 1 time. Okay, the next number that we had was 2. That was another sample mean that we saw, and that happened 2 times, just twice. And then we had 3, and that happened 3 times. The 4 happened 4 times. It doesn't go up. I know you're anticipating it. The next one was 5, but if you're looking, it happens 1, 2, 3 times. And then we have 6 occurs 2, and that 7 down at the bottom only occurred once. It's kind of symmetric, kind of nice there. Now the probability. Probability is the frequency over the total. So total, we had 16 numbers. So if you look at these, this is 16. There's 16 numbers here. If I added up the frequencies, that would also be 16. So for the first one would be 1 out of 16. So the probability of getting a sample mean of 1 is 1/16, which equals, if you use your calculator, 0.0625. For 2 would be 2 over 16, which would be 0.1250. And then what I would love for you to do now, press pause and fill in this chart as well. All right, check your work with my work, or press pause now and copy me, cheaters. But I'm going to keep it pushing. So the next thing, I would like to create a probability histogram for the sampling distribution of the sample means. And that actually is the title of this graph. So go ahead and title it. There's your title. And then, if you remember, we're going to put our sampling means for my horizontal one sampling. Yep, I know that's weird. I'll go away in a minute. And then your vertical axis is going to be the probabilities. So as I'm writing that, I'm going to go ahead and have you press pause. And then also decide on a really good scale for us, because we're going to need one. Okay, so I decided because it's a histogram, you do need to skip a bar here. So my first bar is going to be 1, and then I went all the way to 7 because that was my largest sample mean. And then the probabilities, I decided to go by 0.05 because I had enough spaces to go up to the 0.25, which was my maximum. So if you could please, 1, looking back up, was the probability, it was 0.0625, so I'm just a little bit above the 5 there. And then I'll draw my bar, and then I'll even shade it in just a little bit. Go ahead and graph each 1, 2, 3, 4, 5, 6, and 7. And then we will see how we do. I'm going to pause because writing on this isn't the easiest thing. Okay, so our histogram should look a little bit like this, and this might be the ugliest graph I've ever made, but it's okay. I'm amongst friends, so there's no one judging me. A couple things I do want you to notice. Number 1, this graph is symmetric, kind of like the data was, so everything that you're seeing on the left kind of mirrors what's happening on the right. Also, it's bell-shaped, like our curves that we've been learning for the other part of this one. So looking at it, it does look like it is a normal distribution, and we'll talk more about that in a bit. But for now, let us talk about finding the mean, variance, and standard deviation of the sampling distribution of sampling means. Yeah, gotta say all of that, I suppose. Okay, so finding each of these, the mean, variance, and standard deviation of the sampling distribution of sample means, it's the same process that we did on the previous page, but it's kind of a long, tedious thing because there's 16 that we'd have to do. Like that's the 1, the 2, 3, 4, it's all of those. And so I think you're just gonna have to trust me that if you add those up and then divide them, so again, wait, let's just make sure. I'm talking about all of these. So you're gonna add up these 16 numbers and then divide by 16. If you do that, and you can trust me on this one, and then divide by 16, you're gonna get 4. Yeah, believe it or not. And then if you do the same thing that we did on the previous page and you end up subtracting each of these from 4 and then adding them up and then dividing by 16 again, you will get the wonderful number of 5 over 2, which is 2.5. And then for this one, you would take the square root of 2.5 and you get about 1.581. Now, what you do need to know is that would kind of verify it if we had to go through that great big old wonderfully long process again. But what we're going to do instead of doing that every single time, we're just going to use the formulas. And the formulas that you're going to need are the population and the sampling one, they're the same always. Remember that was 4 equals 4. They're both the same. And then for your other one that's super important, these are things that I'm emphasizing because I would love for you to memorize them. That's your other one. So we'll be using the formulas instead of going through this long process and this long process because no one has time for all that. Okay, so that's going to end this video, and then the next video that will be posted will be all about the central limit theorem. If you'd like to, you can start some homework just upon this one if you want to have a little bit of a break from listening to me talk, and then you'll get to the next video. Thank you.